Alright, welcome everyone. Today we're going to be talking about acceleration. So, I decided to change colors today and we're going to start with blue. Acceleration. Alright, and now we are first going to define what acceleration is. Acceleration is a vector. And a vector, as we have talked about it earlier, has magnitude and it has direction. Alright, and the reason why it is a vector is because the average acceleration, in this video I'll just be talking about average acceleration, is the change in velocity over change in time. Now remember, velocity, as we discussed earlier, was a vector and time is a scalar. So a vector divided by a scalar gives you a vector, and I'll show you guys in a little bit. So now remember how this was the same. Change just means final minus initial, time final minus time initial, and then many books write it as v minus v naught and t minus t naught. Usually t naught, it's always 0. However, sometimes it varies, so it's always good to keep it in mind. And now, just to recall, let's change some colors here. Just to recall that this is a vector and time is a scalar, which will give you a vector. Alright, now just to make this clear, acceleration can exist in either axis. That means it can be on the x-axis, y-axis, z-axis if you have one, but most likely you're only going to be having x and y-axis in non-calculus physics. Now, over the x-axis, what it may look like, you have your surface, and there's a box or a car. Again, I'm not an artist, so just bear with me with the sketches. A car, and you're driving it. Now, if it's moving forward, if it's accelerating forward, it has a positive acceleration. Now, if it's accelerating backwards, it may have a negative acceleration. Now, I want you to understand that the direction doesn't mean the acceleration. So, for example, if you're throwing a rock, or if you throw your pencil right now, or a box up, for a tiny moment, when it leaves your hand, it has a higher acceleration than gravity. That's why it's moving upwards. But the moment it leaves your hand, gravity is acting downwards towards it. So there's an acceleration of negative 9.8 meters per second squared, pulling this box or pencil going down. But for the tiny moment that it left your hand, it was moving upwards. So it was going over the y positive. So at that moment, your acceleration was positive, overall acceleration, which we'll be talking about some of the accelerations and the forces in the next videos. So I just wanted to clarify that direction doesn't mean acceleration. It means velocity, but not acceleration. As you see here, the acceleration is the change in velocity. Now I'm going to make an example just to try to clarify this a bit more. Now, okay, so now I'm going to say, let's actually say that this car, you're driving this car, and you were at a red light, and you were at 0 meters, you were going at 0 miles per second. Actually, mph per hour. 0 miles per hour, and then you got onto the freeway, and you were going 60 mph. And it took you a total of 10 seconds to accelerate that. Now, the first thing, remember, as we did in the previous videos, we're going to convert this to metric system, which is meters per second. mph is miles per hour, so that's a velocity. So it will be 0 meters per second. And 60 mph, remember how we convert this, we say 1 mile 1 mile is equals to 1.6 kilometers. I'm just approximating it. Now this is miles per hour, so hour goes on bottom. So miles cancel out. Kilometers, hours. So let's just convert kilometers into meters now. Now 1 kilometer has 1,000 meters, and 1 hour has 3,600 seconds. Now we're going to put that into the calculator, and it should give us, oh, I do not have my calculator on me, so let me try to open my calculator here. Now we're going to plug in this number. So 60 times 1.6, 2 kilometers times 1,000 divided by 3,600, and it gives you 26.66, which I'm just going to round up to 26.67 meters per second. So that is our final velocity. Now that we have that, let's just go ahead and say the average acceleration, and now we refer back to our formula here, and it's the change in velocity over the change in time. So change in velocity, our final velocity was 26.67 meters per second minus initial, which is 0 meters per second, over time, which was our total time was 10 seconds. Our initial time was 0 seconds. So this is where a lot of people just leave it out. So then this ends up having a total average acceleration of 2.667 meters per second squared. And this is your average acceleration that you were exerting on your car to get it from 0 miles per hour to 60 miles per hour in 10 seconds. It was 2.667 meters per second squared. Remember, your answer is most likely always going to be in the metric system, which is meters per second, or second squared if it's acceleration. And I just wanted to point out that there's something called deceleration as well. So if you are actually slowing down from 60 to 0, then what you would have to do is the same process. So now your final velocity was 0 meters per second minus your initial, which in this case was 26.67 meters per second over a period of 10 seconds. So now it ends up being the opposite, negative 2.667 meters per second squared. And now the negative just tells you that it's slowing your vehicle down, or it's moving it in the opposite direction from where it was originally moving. I hope this video was helpful. Remember to like us on Facebook and subscribe on YouTube. Comment below and let us know if you want us to address anything specific, any questions, any homework that you may not have such a great idea. Let us know and we might try to help you out. Have a good day.